Here we go. Hey, everybody. Happy
Hello.
Tuesday. Hello.
Yeah.
Hello, everyone. How is lab going so far?
Not great.
Not great. What's going on
Could
with
be
lab?
way better.
It's just really
Hard to communicate.
yeah,
Very hard to communicate.
coronavirus just makes it really bad.
Okay. Is it because you're split up into a bunch of different rooms and your instructor's like all over the place? You mean?
Yeah, kind of.
Mhm.
Part of it.
We all did really bad on the I'm speaking for myself, but also I think a lot of people also did really bad on like the pre-lab quiz, which was just a syllabus quiz. So it should have been like 100, and everyone's doing really bad on it because the questions are all weird.
Okay.
And all the resources are like scattered around the As You Learn page, so it's pretty hard to find anything specific.
Okay.
And as Abdel was pointing out, like some questions just seemed flat out wrong.
Yeah, I think to sum it up, it's just kind of like not very user friendly so far.
Okay.
I've been going around to a whole bunch of separate different documents and putting them in one Google document so that I can print it out and have all that
For
stuff
yourself.
ready
Yeah.
for
Okay.
lab when I.
If you do that, then share it with everyone else because that seems like it would be really useful.
I'm still working on it.
Okay. Anything else about lab? I'm happy to be a conduit of information where all of you remain anonymous and I can talk to Dr. Chandra and give him suggestions.
An intermediary.
Intermediary, sure. And feel that way with him too. You can tell him things to tell me if you want. I'm sure he will keep you anonymous as well. But keep that in mind.
Well, for the syllabus, the pre-lab syllabus quiz and everything, he ended up emailing us last night at like 10 and saying that we had 2 extra hours to do it, but it was also 10, and I don't think a lot of us saw that until this morning. And then he gave the Wednesday night lab like an extra whole day to do it, whereas we only got 2 extra hours for the Monday night lab.
Mm-hmm.
Can I just ask, like, everybody in the class, do you guys know where the information of like the priorities for your grade, that question, where was it?
It was
in the syllabus, but it's also wrong at the same time. I want to say that.
So if you're looking for the breakdown and everything at the very bottom of the syllabus, he puts percentages next to each of the types of assignments. It is in kind of 2 different parts. One's kind of at the top, and a more comprehensive list is at the bottom.
Yeah.
Okay. I'll look again. Thank you.
Yeah, I was also just kind of I don't know, with the quiz that he extended for 2 hours last night. We had like 5 of us email him today about it, and he just told us he wouldn't extend it any further. And he didn't really explain why either, and it was just kind of confusing.
Mm-hmm. Okay. Well, thank you so much for your feedback and for your honesty, and keep that coming, because we don't want this class to be more frustrating than it has to be. It's already kind of difficult, so we don't need to make it more difficult if we don't have to. So yeah, thank you. All right, we're going to take attendance. I'm going to ask you to put into the chat your favorite sauce. This could be like a sweet sauce, like caramel sauce, or like a ketchup kind of sauce, or a gravy. My personal favorite is fried chicken gravy, although I am gluten-free now and can't eat it anymore because digestion stuff. So if any of y'all can figure out gluten-free fried chicken gravy that doesn't taste like ass, please let me know. Okay. Let's see. I'm gonna stop sharing for a minute. And look at the chat. I think everybody's had a minute to put their sauce. Thank you so much, everyone. It's good to know. These are good things to know. Yeah, and if you want to put more stuff in the chat about the lab for me to tell Dr. Chandra, please let me know, and I will send those on to you. And this will all be anonymous. I will cut this part out of the recording for the class that I post on YouTube. Okay, so we're gonna move on. Today, we have 3 things we can hopefully get to as far as like a lecture discussion on our agenda. A couple of things first. I tried to see about if we could meet in person, and there is not a classroom where we can fit and be socially distancing, at least in Garwood. There might be one like somewhere on campus. So I'm still checking on if there's a campus location. But it looks like probably that's not going to happen. So we'll probably have to be on Zoom, unfortunately. I'm sorry. But you do get in-person contact with lab at least. You can enjoy it together, right? Or suffer through it together, however you want to think of it. Does anybody have questions about this class or lecture portion? Okay. In that case, we will proceed with talking about reporting uncertainty. That's going to be our first topic today. It was something I didn't really go into last time. And then we're going to talk about uncertainty conventions and deciding uncertainty, but using conventions like, what do I do when I have a meter stick with tick marks? What do I do when I have a digital device like a voltmeter? That's different. What about if I have a counting device that's counting a number of events, like photons hitting a detector or radioactive emissions on a Geiger counter? What if there's no uncertainty given, but I know it's a measured value? And I need to figure out some way to propagate it in my math. Then what do I do then? Lastly, we will be talking about good plots and bad plots, if we can get to that point hopefully today. So our first thing is reporting uncertainty. I do have a PowerPoint here. It's not super long or detailed. I'm going to try to make it fit here so this works on the Zoom screen. Okay. Everybody see this okay? Can you read my text? All right, it does get a little bit smaller. What's up?
I can.
You can. You can? Okay. Thanks. All right. We're going to start with this question. Where does experimental uncertainty come from? Well, when you make a measurement, there is some amount of uncertainty because you can't ever know, you can't ever make a perfect measurement. So there's different reasons it can't be perfect. You can't perfectly know the perfectly exact answer. And that's because the instrument has some limitations to it. If you have a meter stick, you're going to be more limited by that instrument than a vernier caliper. The meter stick is going to have a bigger uncertainty. The caliper is going to have a smaller uncertainty. But either way, it's going to have an uncertainty because it's an instrument. Excuse me. It can also be related to the system, this experimental uncertainty, this measurement uncertainty. Maybe your system is changing over time while you're measuring it somehow. Maybe the temperature changed and the rod contracted or whatever because the temperature changed while you were measuring it. So that's going to contribute to some uncertainty in your measurement. So you have to consider both. You have to think about what might be happening to my system while I'm measuring it. Is it constant? Is it going to change? Make sure you're thinking about that while you're doing your measurement. And then also figuring out what the convention is for the instrument you're using and considering that uncertainty. Okay, so if it's the instrument, you can be like limited by the tick marks, for example. If it's the system, it can be changing during the measurement. So put that in text there. Okay, when we report uncertainties, that means when we like state them in our paper or in our thing we're turning in or our document we're going to share with scientific colleagues, we report the uncertainties like this with a value plus or minus an uncertainty. I am positive you have all seen this before in introductory lab. You may not have seen it written like this exactly with the little delta thingy there, but you knew you were writing like your measured value plus or minus your uncertainty in your lab, either notebook or whatever you were doing in intro lab. So if we're speaking of these quantities algebraically, we use a little delta symbol here to mean uncertainty, measurement uncertainty of whatever the measured value is. That's kind of nice because when we're propagating uncertainties, it's really nice to not have to plug in a bunch of numbers. It's nice to leave that symbolic until the very end and then plug in like 1 times 8 times 10 to the negative for all the different values. Only at the very end. Maybe you remember me mentioning that in introductory physics. Okay, any questions so far? It's mostly review, I think, but please ask me a question if you have one. Okay. There are some different ways to report uncertainties. I'm just going to give you a bunch of examples. Oops, what is that doing there? I'm going to give you some examples instead of a bunch of words. Who wants to read words? No one. We want to look at a slide and we want to see an idea, not have to read a bunch of words. Remember that when you're giving a talk in senior seminar. Okay, so there's the absolute uncertainty reporting method, which I prefer personally. I just like to see the number, the actual uncertainty. You can also state that in a fractional way, which is really weird, and I don't like it, but it's done by people. It's weird because there's no unit here, so it's implied that's a fraction, and that's just weird and confusing to me. But it is a thing. It is a way people report uncertainty. Then we have you just take that fraction and turn it into a percent, which makes more sense. There's the percent there that tells you, I didn't leave the units off, it's a percent. I did that on purpose to give you an idea of how much my value compares to my uncertainty. So that's kind of nice sometimes. If you just want to tell, like, is my uncertainty big or small? Then it makes sense to report it as a percent uncertainty. Then it's like 5.5 plus or minus 80%. That's crap uncertainty compared to 5.5 centimeters plus or minus 1.8%, which is good uncertainty. So, yeah, go ahead.
The other, you had said that you round your uncertainty to 1 sig fig. Is that only for the absolute stuff?
That's right. That's for the absolute, yes. Okay, other questions about these?
Will you be going over how we would like the specific rules when we're like applying other values with different uncertainties to each other? Like, let's say there's two things with two different uncertainties.
Yes, we will be talking about that. We're still in chapter 1 right now of the train wreck book. That's chapter 2, so that's coming soon. So thank you for asking, Ethan. Other questions? Okay. All right, here's some rules. 2 rules, actually. We already went over a couple of rules last time. I just made these up as number 1 and number 2, whatever, just because they're 2 rules I'm talking about right now. We went through over a couple of ones before. Anyway, rule number 1. I think we already actually went over this. Precisions should match. The number of digits after the 0 should be the same for the value and the uncertainty, assuming you're reporting them with the same times 10 to the whatever. In this case, times 10 to the 0. But those have to match. Okay, so this digit has to match the placement of that digit, 10th place, 100th place, whatever. All right, so that's our first rule. Here's a question. Here's a case where that rule is met, right? That rule is okay. We have matching precisions. Let's count 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. Okay. So the same number of digits after the decimal. Is this okay? Is there something wrong with this?
No, you gotta round it, right? Round it to the,
Why?
well, it's an uncertainty thing. I don't know.
Part of a lab quiz actually, because we had to figure out that we were supposed to round it, even if
Why?
it's the matching amount.
I mean, on the first lecture, you told us to always round it to 1 sig fig. That was wrong if you did that on the quiz, but it was, I mean, that's what we knew, and I don't know.
Yeah, you're supposed to, if it's like, it's because it's a certain percentage of the number, right? Because the rules are different for 0.01, then you would, I don't know, it's complicated.
I'm not understanding what you're saying, Henry, but maybe you're right. Well, I mean, on a first glance, this is just like ridiculous with how many sig figs there are. Like, whoever has that many sig figs? Have you ever measured anything and had that many sig figs before? No. So that's kind of ridiculous. It has 4 sig figs. At least the uncertainty does. Or sorry, is that 5? How many is that? What's the rules for sig figs? Are we talking about sig figs in this class? Tristan?
Yeah, that's 4, Dr. Hester.
It's 4? Okay. Tristan, did you have something to say?
Yeah, so if that's 4, then they don't match because the precisions would be different because the 9.8 has 5 then.
They don't have to have matching sig figs. They have to have matching precision. That's 2 different things. But thank you for asking, Chris. We're bringing that up. As long as the number of digits after the decimal match, the 1, 2, 3, 4, 5 here, 1, 2, 3, 4, 5 here, the precisions match. That's different than number of sig figs.
Okay, gotcha.
Yeah. But I'm glad you brought that up. Thank you. Okay. Anyway, usually we don't have like 4 significant figures in your uncertainty is definitely too many. But just this value here, having that many significant figures, this one has 1, 2, 3, 4, 5, 6 significant figures, this measurement. That seems absurd. That's just way too many. So if you ever have a thing like this on a slide in senior seminar, a professor is going to be like, excuse me, what is that? number. That's too many significant figures. That is unrealistic. You know, you did some math and you didn't think about significant figures and you just threw a number up here on your slide. So be careful about that. Okay. And yes, also rule number 2, you should only have one significant figure in your uncertainty. This is a rule in Taylor, in this book, in your error analysis book. Okay. Should only be one significant figure in your uncertainty. So that's also going to be related to rounding. So I think somebody said something about rounding, which we will also talk about in a second. Okay. Sometimes we can break rule number 2, but we have to have a good reason, a really good reason. And if I ever see a uncertainty that has more than one sig fig, I'm going to call you out in senior seminar when I'm your person watching your talk. Because it just like, to most of us, it kind of jumps out as like, just incorrect. So if you do break that rule, you have to like state why you broke the rule. And it has to be like, oh, sorry. It is related to if it would change the percent uncertainty a whole lot. So I'm going to give you an example here on the next slide of what I mean. Okay, so let's say you have this measurement somehow. I don't really understand how you would get this measurement. How would you have 0.123 centimeters uncertainty in the first place? Isn't that just weird? Why would you have that as your uncertainty? It should be like 0.1, 0.01, 0.02. You know, that it just doesn't make sense in the first place. But let's just say you have this measurement somehow, and it if we consider that number, you're going to have a 23% uncertainty with the way it is reported like that. If you change that so that you have one sig fig, you now have in your uncertainty, which means you have to convert your value to match the precision of your uncertainty. So you change that to 0.5. Now your uncertainty is 40%, which is much more than 23%. So that would be a situation where you could maybe keep 2 significant figures instead of 1, just to not skew that percent uncertainty farther from what it actually is. So sometimes you just make a decision and like have a reason, and then you state that when you're reporting it in situations like this. Okay, either way, you always have to round up. Whenever you're rounding, you don't round down with uncertainty. If you're taking a value like 0.123 and you're rounding it to 1 sig fig, you have to round up. If it was 0.101, okay, then you don't round up. That's ridiculous. So there's like a gray area sort of, you know, of how that works. But you should almost always round up when you're rounding an uncertainty, because if you round down, you're underestimating your uncertainty, and it's better to overestimate your uncertainty as a scientist. It's more scientifically honest to overestimate your uncertainty. And we're just talking about uncertainty, not the actual value, just the uncertainty part. Questions about this?
So if instead of putting 0.2, would you put 0.13?
Yeah.
Okay.
0.54 plus or minus 0.13. But to me, that would be like the weirdest looking thing ever. So you would have to state why you have 2 significant figures there. Does that match up with what you're learning in lab?
He had that rule in a very derelict, hidden away document, but yes.
Okay. Yeah, people that teach this class tend to have very wordy documents. I'm trying to not do that to y'all. And just like really condense it down to what I know is important as a senior seminar instructor. So there's still a lot of information that I'm not talking about, like in this document on our As You Learn page. Oh, whoops. Oh no. Okay. So we have this document in week 1, Introduction to Measurements and Uncertainty, which is what I was going through last time. And it's really wordy. There's a lot there. And there's a lot there I'm not talking about. So if you ever don't remember how to do uncertainty for something, just go back to this document and look, because I'm not going through everything in detail. I'm waiting for you to need to know, and then you can go look. All right, here we go. Back to this. Any other questions, comments?
Do we have access to these slides that you're presenting?
I will put them on the As You Learn page. They're not there yet, but they will be there.
Okay, thank you.
Sure. Thanks for asking. Okay. Now, these are not rules, but it just is helpful if you do these things that I'm talking about here. So do not do this where you have times 10 to the different something before and after the plus or minus. Please don't do that. It's still correct. It's just annoying because it's easy to like make a mistake for your reader if you do this. So this is much better. Okay, I can see, I can see that the precisions line up just by glancing at this phrase here of numbers. And it, I can read that easily. The first one is like, oh, I don't want to read that. I don't want to do that math. Okay, even better, prevent yourself from reading more than you have to, or from your reader having to read more than they have to. And you put those two things in parentheses, then times 10 to the minus 18 with the unit on the outside. That's really nice. Okay, definitely don't do this last one, hell no, with two different units. No. I mean, it's right, it's correct, but it's annoying. Don't do that. You don't want to annoy your reader. You don't want to annoy your judge in senior seminar. You want them to be happy. You want them to look at this right here. And then they will feel happy, calm. Okay. Any questions about that? All right. I am going to put you into your breakout rooms and put some questions in the chat for you. And I want y'all to go talk about these questions, and then we will regroup. Okay, so I'm going to put this in the chat so you can be thinking about it while I'm putting you in. Oh no. Did I do that? Oh, sorry. Let me repaste that. It only showed me the very bottom. Okay. I think you should be able to see the questions, and I will put you into your breakout rooms now.
Wait, did you say you already posted the questions or?
Yeah, in the chat, can you see them?
No, I don't see. I
Oh,
don't
sorry.
see the question.
There they are.
I can't see them either.
Are they
Okay, I
there
see 'em.
now?
I see them.
Okay,
Yeah.
thanks. I forgot to hit enter. All right, people, did we get to all of the questions, all of the numbers? Yeah, I have one nod, okay? One thumbs up, cool. All
I
right,
only did the first two.
sorry, say that again?
In my group, we only got to the first two.
Okay, no worries. Well, let's get your group to answer the first one then. Was that Brendan talking?
Yes, ma'am.
I recognized your voice. That was really wow.
Oh, yeah, it was me.
Okay, so where are you? All right, somebody from Brendan's group, please tell me how the first one should be reported, or you can type it in the chat if that's easier.
I'll just do it. We said it would be 1.5 plus or minus 0.2 grams.
Okay, sounds right to me. Anybody want to argue with that, or we all agree?
Why would you round like the actual number if you're not certain about the second decimal place?
Good question. Because let's go back and look at that rule. I'm gonna share my screen for a moment. Thank you, Abdel, for asking. Let me find that rule. You should only have one sig fig in your uncertainty, right? So that's why we changed it in the first place. And then, can y'all see my screen?
Yeah.
Okay. And then our other rule is that the precisions have to match. So if we change the precision of our uncertainty, we have to also change the precision of our measured value. They have to match.
Oh yeah, I know. That's what I'm asking.
Oh.
What I'm asking was, so in the original number it was 1.45. We don't care about the rest for now. If your sig fig, if your uncertainty was to one decimal place at 0.2, wouldn't that mean the number would be 1.4 instead of 1.5 because you can't really round up that number
Okay,
itself?
yeah, good question. You still round up the value. What the hell happened to my camera? I don't know what's going on. I don't know. Oh, okay. Somehow my camera got turned off. Sorry. I'm gonna try to share my screen again so I can talk with looking at a number. Okay. So the value, the actual measured value, you still round normally with the regular rounding rules. But the uncertainty, you always round up.
Ah, all right. I see. Thank you.
Okay. Okay. Thank you for asking. Okay. Let's see. Did anybody get to the last one? Any group get to the last one?
I had done the last one.
Okay, Ethan, what's the last? How are we going to report that?
I reported it as 1,454 plus or minus 9 meters times 10 to the 12.
Okay. Does everybody agree with that? No, Sean, what do you think? What should it be?
My group said we would change it to I'm sorry, 1.5 plus or minus 0.9 times 10 to the 15.
Okay, how'd you get the 0.9?
So we moved the decimal so that the scientific notation would match. So they both be times 10 to the 15. So then it was 0.843. And then we just rounded that up to 1 sig fig.
Where'd you get that from in the first place? The uncertainty.
I think she's talking about the last one, Sean.
Yeah.
Oh.
The very last one.
Yeah, Sean was talking about the second one. But
Oh, I'm sorry.
Crap. I'm so sorry.
No, that's my bad. I thought though.
I don't even know if what you said was right. I was completely looking at the wrong thing.
It's okay.
Maybe you were right too, Ethan. Did you think I was talking about a different one? Crap. This is why I need to
were
be
you talking
sharing
about
my-
the second? You weren't talking about the second one?
I was talking about the last one. Damn it, I'm just gonna share my screen.
It's a,
right
my
there.
group we didn't understand how to do the last three.
Okay, well, let's talk about that real quick. So the last three had no uncertainty reported at all, right? So let me get those numbers pasted over here. Okay, here we go. So if we have 1.4569, then we have to do something where we imply the uncertainty. And maybe I didn't quite tell you this yet, but if you're given a measured value and you're not told what the uncertainty is, but you know it's a measured value, then there is a rule that we follow for implying that uncertainty. So if this was a measured value, which was still kind of ridiculous with the number of significant figures, we would take the most precise place, so that place where the 9 is, and we take that and divide by 2, and then round up. So the uncertainty in this case is going to be 0.0005. Is that the right number of zeros? 1, 2, 3, 4, 5. 1, 2, 3, 4. Yeah, and then 1, 2, 3, 4. So in this case, we would imply this as the uncertainty if that is the reported measured value, and they don't give us an uncertainty. We take half of the least count. That's what that's called. You may have heard of somebody saying half of the least count, at some point. So you would follow that same procedure with the last 2 values in the list and just have the proper times 10 to the whatever for those.
I have a quick question.
Sure.
Does it matter where you put your units? Do they need to be in both, or just the first one, or just the second one?
Good question. So let's look back at that nice slide that tells us the conventions over here. Okay, so I like the parentheses to be there. It's the most correct to me to have the parentheses there. But some people do this, where they don't have the parentheses, or I'm sorry, here, where they don't have the parentheses. And it's implied that coulombs is for the entire expression. But in this case, it is definitely for sure that coulombs is for the entire expression. So you could do it either way, but it's better to include the parentheses. Other questions? All right. Hey, Ethan, can you tell me again, what is this what you were trying to talk about? The second line in the chat that I put up there? Was that what you were giving me an answer for?
Yeah, I was giving an answer for the second one.
Okay, can you say that again, please?
I had gotten, I realized I could have written it a different way because I had it in meters instead of something else, but I got 1,454 plus or minus 9 meters times parentheses times 10 to the 12.
Okay. I'm gonna need to put that into a document because I don't really have enough time to type it into the chat. I think you're correct. I don't know if that's the best way to report the value.
But what I could have done is I could have changed it to millimeters instead of meters, and then have the
or nanometers or picometers.
Yeah, or I could have like had it in like had converted it into like 10 to the 15th instead, and then it would be like a different unit.
Mhm.
Yeah, I just wanted to keep it in meters for some reason, but because that's SI. but-
Yeah, that's something I totally forgot to put on that slide is if you're dealing with times 10 to the 12 over and over and over, just change it to pico and put a little p there instead of times 10 to the 12, negative 12 all the time. Thank you, Ethan. That's a good point. I will write up solutions and put this on the As You Learn page for everybody to see what those should be and how we did the, I see Tristan's question now. Why is the uncertainty not 0.0005 if we were taking half a least count? Because the uncertainty has to have the same precision as the measured value. And so if we did that, Tristan, the precision would be better than the measured value precision because the number of digits after the 0 has to match up.
So in that case, we would take half of the second to least count, I guess.
Yeah,
Okay.
you can think of it that way. Okay. I have 2 minutes. We're going to quickly look at some more information and then we'll talk more about it next time. All right, back to sharing my screen. And nope, not that, sorry. I wanted to show you some highlights from this super long document, this 20-something page document. I highlighted some certain parts that are really important for deciding uncertainty. So I'm going to page down, and where we have something highlighted is where we're going to pay attention. Okay. So there were 3 or 4 things in my agenda list. We had the like analog measurement where you have like a tick mark kind of situation. We have the digital measurement where you have like a digital output with a certain number of digits. And then we have like a counting situation for a number of integer of things, counting something in time. So we're going to do a quick example with at least this pen, the measurement of this pen. Okay, and then we're going to do an example with measuring something off of a digital display, and then we'll talk about the other one really quick. So if we have this situation, this pen on this meter stick, what we do first to report the uncertainty is to figure out the smallest increment or distance between tick marks on my measurement tool. So I have a centimeter here divided into 10 for all along the thing, and so the smallest increment is 0.1 centimeters, a tenth of a centimeter. I can read 21.4 centimeters if I take from the 16 to the 30, whatever, 30 points, whatever. I can read 21.4 centimeters of the length of this pin. And I can estimate that the end of the pin is, assuming this is completely perfectly lined up with 0 here, the end of the pin is at like 0.2, out of a tick mark, 0.2 across a tick mark. Okay, so I can estimate that. All right, now I'm going to see if I can split that into segments. How many segments can I split that into? 1, 2, 3, 4, 5. How many segments can I split my smallest tick mark into? And I decided by looking at that, I could maybe split it into 4, and I could tell, about how far across, I could divide that tick mark into fourths and see that end of that pin at some like fourth across, at 1/4, 2/4, 3/4, or all the way. So that smallest increment that I can judge based on my personal decision is 0.025 centimeters. But that uncertainty is 2 digits. So I need to round up to 1 digit. So it's going to be 0.03 centimeters. Based on my like ability to see how far in between the tick marks. Maybe you can choose a different number. You're going to have a different uncertainty if you have better eyesight than me. And that's okay. You just have to explain where that came from. So my final reported measurement is going to be 21.42 centimeters plus or minus 0.03 centimeters. I'm going to stop there. And do we have questions? Thank you for staying a little long.
I have a quick question that might be kind of silly. About sig figs, just a refresher. So if there's a 0 directly after the decimal, that 0 doesn't count as a sig fig, right?
Okay. Correct.
That's it. That's all I had.
Okay. That's true if you don't have any digits before the 0. Right? Like if you have 0.0001, the zeros don't matter, sig fig wise. That's one sig fig. But if you have 21.00001, those are all sig figs. Right? Everybody? Yeah? Okay. We're a team here. You got to remind me when I'm right.
Sorry, it's just been a while since I've had a lab, so
No
I haven't
worries. Yeah, it's
got sig
okay.
figs in a
And yeah,
while.
I'm not going to go over all those little bitty details of sig figs, but they're all in that document that I was just showing you. So if you forgot something, it should be in there. You just have to read it. Sorry.
All right, great. That's good. Thanks.
Use the search function. Okay, other questions? Anybody?
So, hopefully we can like mitigate a lot of these issues with measurements we're actually taking if we just like record it a certain way to start with instead of trying to like convert from the crazy things.
Yeah. Yeah, I was just giving kind of ridiculous examples here.
Like that pin that bothered me. I was like, why did they start there? Just move it to the end, you know?
Yeah.
Okay.
Yeah, but when you are doing this in the lab, I mean, if you're going to take a meter stick and like decide an uncertainty, it's just weird for it to have more than one sig fig. Like, why would that even happen? You know, you're
Yeah.
going to take that thing in between tick marks. You're not going to divide it into 0.123. You know, you're going to divide it into a fourth, a half, 3/4, you know, or whatever. And then round to one sig fig. So I don't know. It's hard for me to not see that. Although there are different rules in chemistry, everybody. They do have more than one sig fig in chemistry sometimes, or I guess frequently. So this is physics. Chemists. People in chemistry classes. Okay, other questions? Supposed to stop now. So
Is Jupyter Notebook a separate download from Anaconda?
oh crap, I forgot to talk about that. No, it's all kind of one thing. Anaconda does it all for you. It's actually pretty easy. Just go through the document and like follow the steps. And thanks for bringing that up. I will send an email about that assignment. This should be not a big deal. It should be like you're following directions, basically. Okay. Everybody have a great day. I'll see you Thursday.
You too.
Bye.
Have a good day.
You too.
Thanks, doctor.
Thank you. Bye.